Hello everyone, I am Ümit Alkuş. In this video, we will solve one problem in chapter 27. A. Find all the currents for the circuit shown below. In order to solve this part, we use the following procedure. First, determine the number of currents. Assume completely arbitrary direction for each of them. Let I1, I2, and I3 be the currents for this circuit. 2. Write down the first current equation. For the junction shown by blue circle, input current is I1 plus I2 plus I3 and the output current is just 0. We call this equation as 1. 3. Put the necessary signs for the circuit elements. For the batteries, the positive sign corresponds to the long stick and the negative sign for the short stick. And for the batteries E2 and E3, we have plus and minus signs like this. For the resistors, the discussion is different. For example, for resistor R3, which is 1 ohm, the current is I1, which flows to the right. And because current flows from high potential to lower potential, we write plus sign here and negative sign here. For resistor R2, which is 3 ohms, the current is I2. By the same way with the previous discussion, plus sign goes here, negative sign goes here. For resistor R1, which is 2 ohms, the current is I3, which is to the right, so the signs are placed as the following. Finally, for resistor R4, which is 4 ohms, the current is I3, so the signs are placed as the following. 4. Write down potential equations as much as you need. There's a thumb rule here. The number of unknowns, which are I1, I2, and I3, is 3. Therefore, we will find 3 potential and current equations. One of these 3 equations has already been found as equation 1. Therefore, we have to obtain 2 voltage equations. For convenience, we choose one point on the circuit. And we choose one path, say I, so that we leave A and again we reach A. Finally, we find the total voltage drop along this path. First, we have potential at point A, which is VA. For resistor R2, we take the upper sign, which is negative, for the voltage difference. So the calculation is 3 ohms times current I2. For resistor R1, we take the leftmost sign, which is positive, for the voltage. So we have 2 ohms times current I3. For battery 1, we take the leftmost sign, which is plus. And the voltage is 6 volts. For resistor 4, we have the corresponding sign as plus. Then the voltage difference is calculated as 4 times I3. For battery 2, the rightmost sign is negative. And the voltage is 24 volts. As a result, we reach the potential at point A after this travel. VAs on both sides cancel each other. On the left hand side, we have negative 3I2 plus 6I3 minus 18, which is equal to 0. And if we divide both sides by 3 and rearrange the equation, we obtain negative I2 plus 2I3 equals 6. And we call this equation as 2. In order to find the last voltage equation, we use path 2 to go from A to reach A. Now the first voltage is VA. And for resistor R2, we take the upper sign, which is negative, and the voltage is calculated as 3 ohms times current I2. For battery 3, we take the lower sign, which is negative, then the voltage is 15 volts. For resistor R3, we take the leftmost sign, which is positive, and calculate the voltage as 1 times I1. And finally, we reach potential at point A. VAs on both sides cancel each other. As a result, we obtain the equation negative 3I2 plus I1 equals 15. And we call this equation as 3. From equation 3, we can write I1 equals 15 plus 3I2. And we label this equation as 4. If we put equation 4 into equation 1, we get 15 plus 3I2 plus I2 plus I3 equals 0. Hence, we obtain the equation 4I2 plus I3 equals negative 15. And let's label this equation by 5. From equation 2, we have I2 equals 2I3 minus 6. And call this equation as 6. If we put equation 6 into equation 5, we get 4 times 2I3 minus 6 plus I3 equals negative 15. Or 8I3 minus 24 plus I3 equals negative 15. Simple calculation gives us 9I3 equals 9, from which we obtain I3 as 1 ampere. If we put this value into equation 6, we get current I2 as negative 4 amperes. From equation 4, we have I1 equals 15 plus 3I2. We know I2 as negative 4 amperes. Therefore, I1 is 3 amperes. If you notice, the negative sign in I2 means that the direction of I2 that we have chosen was wrong. Then the correct direction is its reverse, that is, downward. B. Determine the potential across the resistor R2. To solve the problem, we use 3 ways. Using the upward direction, we can go from A to B. The potential at point A is VA. For R2, we take the negative sign and calculate the potential as negative 3 times I2. Finally, we reach the potential VB. Then, VA minus VB equals 3I2. We know I2 as negative 4 amperes. Therefore, we find negative 12 volts. Another path from A to B is to the left. The potential at point A is VA. For battery 2, we take positive sign. So, the potential is positive 24 volts. For resistor R4, we take negative sign, so the potential difference becomes negative 4 times I3. For battery 1, we take negative sign, so the potential difference is negative 6 volts. For resistor R1, we take negative sign, so the potential difference becomes negative 2 times I3. Finally, we reach potential VB, from which we obtain VA minus VB equals 6 times I3 minus 18. I3 is 1 amperes, therefore we obtain negative 12 volts. As you see, the result is the same with the previous one. Finally, from A to B, we can use this path, which is to the right. First potential is VA. For resistor R3, we take the negative sign, so the potential difference becomes negative 1 times I1. And for battery 3, we take positive sign, therefore the potential difference becomes positive 15 volts. So we obtain potential VB, from which we get VA minus VB equals I1 minus 15. I1 is 3 amperes, therefore we obtain negative 12 volts, which is the same with the previous ones. C. Calculate the power for each circuit elements, indicating whether they are supplied or dissipated. For resistors, the power is calculated by the formula I squared R. Or, for the potential difference V, we have V squared over R. By the same way, we have V times I. And this power is always dissipated. For batteries, if current flows from low potential to high potential, power is calculated as V times I, and which is supplied. Or if the current flows from high potential to low potential, again the power is calculated as V times I, and it is dissipated. The power for battery 1 is calculated by the formula epsilon 1 times I3. With the numerical values, we have 6 watts. And because the current flows from high potential to low potential, this power is dissipated. For battery 2, we have the power epsilon 2 times I3. With the numerical values, we have 24 watts. And because the current flows from low potential to high potential, it is supplied. For battery 3, we have the power epsilon 3 times I1. With the numerical values, we get 45 watts. And since the current flows from low potential to high potential, it is supplied. For resistor 1, we have the power I3 squared times 2 ohms. I3 is 1 ampere, therefore the power is 2 watts. If you remember, it is always dissipated. For resistor R3, we have the power I2 squared times 3 ohms. I2 is negative 4 amperes, therefore the power is 48 watts, which is dissipated. For resistor 1 ohm, we have the power I1 squared times 1 ohm. I1 is 3 amperes, so the power is 9 watts, which is dissipated. For resistor R4 we have the power I3 squared times 4 ohm. I3 is 1 ampere, hence the power is 4 watts, which is dissipated. As the final remark, if you calculate, the supplied power is equal to the dissipated power. Namely, 69 watt power is supplied and 69 watt power is dissipated. Okay, this is the end of the discussion of this problem. Thank you for your attention. See you in the next video.